All right, guys. Today we want to talk about some things that have to do with measuring things, uncertainty. Okay, and we've been looking at this idea that chemistry is a lot of stuff, and one of the main things it's about is, unfortunately, doing a little bit of math. Well, when you're measuring stuff, and you got to use the math to do it, there's a certain way to do it. Okay, and one of the main things that we're going to be looking at is what happens when you're not sure about specific numbers. There is no absolute, okay? So we will look at some uncertainty in measurement. Now again, when you're reading like a scale, right, or you're reading a thermometer, and you're looking at that temperature, you're looking at that mass, well, when you measure that stuff off, there's always going to be some uncertainty. The number that you estimate is going to be the uncertain number, okay? It's always going to be that. And there's always going to be some measurement in uncertainty in this particular field, because I mean you can't do that. You can't measure everything perfectly and accurately. Now, why? That's the main question for us today, is why do we have this uncertainty? Why do we not know what's going on? Why do we not have this ability to go, okay, there's a little bit something wrong here? Well, you got to remember, every time you measure something, you're measuring with instruments. You're reading it off a scale, you're looking at a thermometer, you're using a meter stick, whatever you're doing, you're using an instrument to do that. And the thing is, instruments can't read to an infinite number of places. They can't do that. You can't look at your meter stick and have an infinite number of little markings on it that tell you the distances. And your scale doesn't go to infinite number of places when you read it. This doesn't do that. So again, if we look at these things and we go, okay, these things are going to have some uncertainty in them. Now, which ones are the most uncertain, which ones are the least uncertain? So if I take this one right here, this scale right here, that's pretty uncertain. That's a very simple scale. You see these all the time in places like the grocery store and places like that, right? This one, however, this is the triple beam balance, it's a little more accurate, or it has a little more certainty to it because you can measure a little bit closer. And then something like this, which is a digital scale, can measure quite a good bit, so its uncertainty is even smaller. Okay? But again, whatever kind of equipment you use, there's always going to be some uncertainty with measuring that equipment. Okay? Now, that leads us to two words that you've heard, I know, 1,000 times: precision and accuracy. Now, most of the people, and this is what we talked about Friday, most of the folks go, well, aren't they the same thing? Precision and accuracy. Most people use them in the same context, but they're not the same thing. Not when it comes to scientifically, okay? There is a difference. Accuracy is the agreement of a particular value with the true value. What the answer is supposed to be, how close are we to the right answer? Precision refers to the degree of agreement among several measurements made in the same manner. Okay, so pretty straightforward there. How close are we to each and every body that we're doing this? And I'm going to show you what I mean right here. If I look at this dartboard right here, and you can see the three arrows here. Are they accurate? Are they precise? Are they both, or are they neither? Well, if you take a good look at them, there's one right here in the blue, one in the yellow, and one right there on the red and the white. Well, here's the Duhan statement. They're neither. It ain't accurate. If they were accurate, they'd be closer to the bullseye, right? If they were precise, they'd be closer to each other. The second one here, you got all these arrows, all three of them, in the yellow area. They're all in the same area. So are they accurate? Are they precise? Are they both, or are they neither? Well, this is precise, but it's not accurate. They're hitting the same area. You're all hitting the same spot, but you're not accurate. You're not hitting the bullseye. And then this last one here is obviously all three of them hitting the bullseye. You're accurate as well as precise, right? You're hitting all in the same area, and the same area is the area you're supposed to be hitting. So that makes this one accurate as well. So there is a difference between accuracy and precision, okay? All right. Now that leads us to when we do have problems with uncertainty and we get some errors in the way that we're coming up with our math, okay, doing our stuff. Well, there's two basic types of error. The first one is called random error. Okay? Random error, as its name implies, is random. An equal probability of things being up or down either way. Okay? Sometimes you'll hear the big fancy word called indeterminate, which means you can't determine what's causing the error in the first place. Okay? And then the other type is called systematic or determinate error. What that basically means is you are sitting there and you're shooting an arrow like we saw a minute ago, and it's all going in the same spot every time, but it's not at that point. You're aiming it at the bullseye, but you're hitting 6 inches low and to the left. Well, that's something you know that's going wrong. Probably your sight is out of whack, or you're just not aiming very well and you're aiming at the wrong spot. Okay? That's something you can figure out what's wrong and then hopefully correct it, either by the instrumentation or by the technique that you're using. Okay? Now, that is a very common thing that we see all the time is systematic error can be fixed quite easily. Okay? Random error you can't really do anything about. It is what it is, and it's kind of hard to stop. So again, we want to try our best to stop all the systematic errors. The ones that we know we can fix, we got to fix those. The random ones we really can't do anything about. But the better we are as far as doing what we're supposed to do, the way we're supposed to do it, the less likely we're having any kind of error. Okay?